Right then, so you may have seen things returning from space and lighting up, and the common misconception is that this is due to friction and the friction of the air flowing over the surface of these bodies, whether it's a rocket or an asteroid, or a meteorite, I suppose, when it's in the atmosphere. There is obviously friction with the air and air resistance, but what causes that glow is actually compression of the air in front. And this is something that causes a great deal of drag on cars and things. But if you do it very rapidly, you compress the air so quickly that the heat inside increases. It can't get rid of the heat to the surrounding atmosphere quickly enough. Now we have a little demonstration of this here. This is a fire piston. It's basically just a bike pump that's been closed off at one end. So I can press this down, squashing the cylinder of air inside. And you might be able to just make out a little white fluff at the bottom. That's just a bit of tissue, just a little bit of normal kitchen roll, nothing special or any special effects here. But what happens when I compress this is I compress it so quickly that the temperature doesn't have enough time to equalize the outside atmosphere. It can't exchange energy quickly enough, so the temperature inside increases very rapidly. If you're familiar with your ideal gas equation, which is PV equals nRT, you might be confused as to why this is the case. But the ideal gas equation only applies in isothermic conditions, where the temperature is able to exchange evenly with the atmosphere. This is adiabatic, if you want your technical terms, and hopefully fairly impressive. So what I'm going to do is squish it, compressing the air and increasing the temperature. And that is what happens when you compress things too quickly for the temperature to equalize with the atmosphere around them.